Okay. Assalamualaikum warahmatullahi wabarakatuh. Very good evening. Okay. Today I want to talk about the transmission media topic. Okay. So let's look at the content of this topics. Okay. Basically, it says that mentioned here that we need to actually the content of these slides of this topic ni you already learn this okay in datacom course. Okay, so this one is just to recall again recall back what you learn in datacom. Okay, so basically they want us to to have a basic knowledge on what is a network. Okay, and then they look at the physical component. Okay, the physical component including the type of cables. Okay, uh, that are used to establish the network. Okay. So in the objective, okay, define, okay, explain what is a network. This is very basic lah, okay. Identify the basic components of network and describe, okay, the mechanism for communication over network. Basically, describe the type of physical medium, the type of physical medium. Okay, so that's the content lah. Okay, because I've done this the Malay version of this slide earlier. So I guess this slide ni will become a little bit more faster, okay, then the compared to the Malay version. Okay, never mind, it's okay. Okay, so it mentioned here that network are comprised of at least two end station and a medium. Okay, so you must have at least two end station and a medium. Okay, which data can be carried. So this is what they mention. Okay, but when you learn in datacom, actually a network ni consists of five components. Okay, to be specific, you must have number one, sender. Okay, sender can be in this case end station lah. Okay, is a sender, or you must also have a receiver. Okay, this one can be anything, and host, handphone, servers. Okay, laptop, anything lah. Okay, any device tu can be sender and receiver. Okay, so one end must be sender, one end must be a receiver. Okay, number three, medium. Okay, number three, this one is medium. Okay, and also you must have a protocol. Okay, protocol that define how this host can communicate. So in this case, we use TCP/IP. Okay, the standard is TCP/IP. And number five, we must have a message. Okay, if you forgot these five parts, please refer to your datacom slides. Okay, so we have these five: sender, receiver, medium. Okay, medium. This medium can be either one lah. Okay, one is, as mentioned here, within the enterprise, the medium exists in a variety of form, from physical cable to radio wave. Okay, so meaning that this medium, you can have a guided medium. Okay, this one I just recall the one that in datacom course, guided medium, which is wired lah. Okay, you have a cable, you have a conduit kan, you have you guide the signal in a cable. And another one is unguided medium. Okay, unguided. This unguided means wireless, nah? Okay, wireless or radio wave. Okay, this also wireless lah. Okay, Wi-Fi, Bluetooth. Okay, this one is a type of network that are unguided. Wired, you can have Ethernet. Okay, minimal lah, PPP, minimal, guided medium. Okay, so basically medium you can have guided and unguided. Guided means wired. Okay, unguided means wireless. Okay, that was the datacom during masa when you learn datacom, data communication course that was mentioned in the slides. Okay, this slide start with a coaxial cable. Okay, coaxial cable. So for the Malaysian, I guess when you watch Astro, the cable that being used by Astro is coaxial lah. Okay, but in this example, okay, it's mentioned here that this coaxial cable, I hope you know the structure, kan? If we make the slide bigger here, okay, here you can see that there's only one in a cable tu, there's only one line lah, copper line here to transmit the signal. Okay, so basically, okay, when we talk about coaxial cable ni, it is they represent more a historic form. I mean, at early stage of Ethernet ni, okay, Ethernet, we did have a shared network. They call it a shared network. Okay, so this shared network, they use coaxial cable. Okay, cable. Okay, they use bus topology. Bus topology, and all the host, the network cards is all half duplex mode. Okay, we will talk about half duplex mode later on. Okay, so at early stage, before we call it Ethernet though, we have this thin net and thick net. Okay, so what is this? This is this cable, this type of network are using thin coaxial cable, okay, and for 10 base 2 here and 10 base 5 for thick coaxial. Okay, so before I explain this, okay, let me share with you what is the meaning of this part ni. Alright, okay, okay, view this one. Just hold on. Okay. 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 So here you can see, let me zoom in. Okay. Oh. Zoom out. Okay. So you can see here that if you have 10 okay. So if you have 10 base 5, for example, the 10 to shows the speed. Okay, 10 means 10 megabit per second. Okay, this 10 means 10 megabit per second. Okay, and the next part you have base. base. Base here means, delete this one first, hold on. Okay, the word base here stands for baseband. Okay, okay, what you mean by baseband? Hold on. Okay, so what you mean by baseband here? It means the Ethernet ni are using is a type of network that use baseband. Okay? Meaning that in Ethernet only one carrier frequency is used. Okay. So in contrast with broadband, for example, okay, we will talk about this in detail later on. But basically, you have baseband and broadband. Okay, so for Ethernet, is always baseband, meaning that whatever signal frequency in the Ethernet is only one carrier frequency. Okay, so but for broadcast, sorry, not broadcast, this one broadband. Okay, for broadband, for example, you can have multiple frequency. Okay, uh, uh, transmit in the multiple frequency signal that you can send in one cable. Okay? So you can have a voice frequency, and you can also have data, normal data frequency, or you can also have video frequency. Okay, so but in Ethernet, okay, they only use one carrier frequency. Okay, that is what it mean by baseband here. And the third, the last part, okay, the last part is a segment. Okay, is a segment type or the segment length. Segment here means network segment lah, the network segment. Okay, the network segment. So if you have here digit, meaning that something like this, 10 base 5, 5 is digit. 5 here shows that it is a 5 meters long. Okay, sorry, not 5 meters, 500 meters. Okay, 500 meters. Okay, if 10 base 2, for example, 2 here is a 200 meters. Okay, actually the cable, okay, is the maximum. Okay, the signal can go through before attenuation happens. Okay, is 185. Okay, but it's almost 200 meters lah. Okay, so how long? This shows how long you can use this cable. Yeah, how long you can use this cable before attenuation happen. Okay, that is if you have numbers too, that shows the distance lah. Okay, before the attenuation happen. So if you have this cable is mentioned there, the maximum is 200 meters. For example, you cannot use the same cable for 300 meters lah. Okay, so up to the maximum 200, then you need a repeaters to you need a repeaters lah in order to transmit the signal. Okay, or else the signal become attenuated, very weak, and we will lose a lot of information from there. Okay, so there will be error. Okay, because of the attenuation. Okay, and the last part, okay, if it is a letter, let's say you have T here. T means twisted. Okay, T means twisted, and if you have F, it means fiber optic. Okay, so if it's a letter, it identify the physical type of the cable, whether it's a twisted cable or whether it is a fiber optic cable. Okay, that is how you read this part. So it's mentioned here that, okay, it is, oh, okay. So it's mentioned 10 here means 10 megabit per second. Okay. 2 here means almost 200 meter. You can use this cable, this type of cable. You can use, the maximum is 200 meters before you need a repeaters. Okay, repeaters. Okay, so because the signal will travel, okay, and it become attenuated, okay, become weak, attenuated or become weak lah, the signal. Okay, so after 200 meters you need a repeaters so that you can uh, make the signal strong again lah. Okay, and transmit. So this is what it mean by maximum transmission distance. Okay, I hope you already learned this in apa tu, datacom. Okay, so 10 base 5 here means how is 500 meters lah. Longer, longer with the same speed, which is 10 megabit per second. So that is what it tells you lah. So early stage of Ethernet ni, you have this thin net, okay, to refer to 10 base 2, and you have this thick, 10 base 2 here. Alah, 10 base 2, okay. Thick net here is 10 base 5. Okay, so that is about the coaxial cable. So let's look at this part, Ethernet. Okay, uh, uh, this Ethernet, okay, compared to coaxial cable just now, okay, you have in coaxial cable you have shared network, okay, and you use coaxial cable, cable, and it is all half duplex, okay, and most of the time they use bus topology, okay, bus topology, okay, the bus topology, okay, okay, this type of topology lah. This at earlier stage, early stage of Ethernet, early stage of Ethernet. Nowadays, okay, nowadays, now what we have a switch network, okay, and we always use either a twisted cable, twisted or fiber optic cable, okay, and most of the time it is full duplex, okay, and most of the time the design, the topology that we use is star topology. Okay, I hope you know lah what it means by star. You have a switch here, and then you have a PC1, PC2, okay, and PC3 lah. So you have this kind of topology. We call it as a star topology. So for Ethernet, okay, there is what we call this, like a history lah, okay, of this Ethernet. You have fast Ethernet, okay. So fast Ethernet, okay, I hope you know by now, fast Ethernet too is 100 megabit per second, okay. This you have to memorize lah, okay. Oh, fast Ether, okay, fast Ethernet, you have 100 megabit per second. Then you have giga, okay. Giga is 1 gig, okay, per second, okay, 1 gig, gigabit GBPS, okay, 1 gigabit per second. So here, here is mentioned that for gigabit Ethernet, okay, the cable that you can use for gigabit Ethernet is 5 E and above. So what is uh, the meaning of this? This one is 10 megabit per second, and T here means twisted. Okay, twisted. And if you use this type of cable, the category, so you can see here category. You can normally you can see cat 3, cat 4, cat 5. Cat here means category. Okay, the category here of twisted pair cables. Okay, the distance is 100 meters. Okay, the distance, I mean the maximum length, maximum length of this cable is 100 meter. Okay, and also you also have here, okay, this 100 base T here is, it means 100, so 10 here means 10 megabit per second. 100, hold on. Okay. So 100 here means 100 megabit per second. Okay, this refer to fast Ethernet. Okay, and 1000 here means 1 gig per second. This refer to gigabit Ethernet. Okay, and TX here is twisted. Okay, all the cables is twisted pair cables is twisted like this. Okay, and and the distance, okay, is 100 meters. Okay, so you take cat 5, you take cat 3 and 4 and 5, then the most you can go for one cable is 100 meters. Okay, after that 100 meters, okay, so let's say you have a hose here. This one I repeat again and again lah. Okay, so if you have hose here, you use this cable. Yeah, okay, if you, and the maximum it can go is 100 meters. Yeah, after this 100 meters you need a repeaters. Before this you need a repeaters. Repeater, so that you can continue to transmit this signal again. Okay, so if you exceed 100 meters here, let's say you go for 200 meters, for example, what happen? The signal will lost. Okay, the signal too will attenuated. Attenuated means that it become weak. It become weak, and most of the time, all the energy to become heat. Become heat lah in the cable itself. Okay, so this one is just the progress of this Ethernet. It goes from fast Ethernet that are using Cat 5, okay, that support 100 megabit per second, and now we have gigabit Ethernet that can use Cat 5e. We also have Cat 6 and Cat 7. It's not mentioned here. Right? After 5, you have 6, Cat 7, okay, and higher. Okay, so this is I hope you can memorize this part. Okay, so and also this part telling you that if you exceed the limitation of 100 meters for all this cable, this signal will become attenuated, and you will get error in your transmission error. Okay, I mean your signal though. Okay? Okay, so let's go to next part. Okay, nowadays we use fiber optic. Okay, so fiber optic, you can see here, it's mentioned F. F here means fiber optic cable. So FX is also fiber optic. Okay, but here the speed, this one is 10 megabit per second, this is 100 megabit per second, fast Ethernet, okay, and this one is to support gigabit Ethernet. So here you can see LX, L means long wave lah, atau long haul, long wave, okay, and S here mean short wave, okay. So here, the keyword here, when you use fiber optic, the physical medium, you already learned this in datacom. The physical medium is a glass, okay? It's a glass lah. Okay? You have a glass here, right? And you have two types, You have single mode and you have multi-mode fiber, okay? So most of the time, when you use fiber, the distance that you can cover is up until 2 kilometers here, okay? 2,000 meter is equals to 2 kilometers. So it's very long distance, okay? Why? Because when you use fiber optic, okay, you use light as a mean of the signal transmission. Okay, it's different with electrical signal when you use twisted. Okay, so you use light as the mean of the signal transmission. So when you propagate the signal, okay, you must propagate this. Okay, this one is a glass, okay. So what happened, okay, when you send the signal, okay, for single mode fiber, okay, for single mode fiber, you can have a very small, very tiny micrometers lah, hold on, continue, okay. So you can have a very small glass, okay, inside that. So sometimes in datacom they said core, glass core, okay. So here you can have a very tiny lah, channel, and you transmit the light within this channel. So this is single mode, okay. So for multi-mode, okay. So for single mode, you can see that it can go until 5 kilometer, okay, because the signal though, they can go straight, okay. But in multi-mode, what you have in multi-mode here, by using the angle of reflection, okay, in physics you learn this angle of reflection, okay. Angle of reflection in sending a light, kan? So you can have a bigger glass, okay, a bigger glass, okay? And when you send the signal, depends on the angle of reflection, okay, this signal will reflect here and then go here and then go here and go here throughout the channel, okay. And you can also have another light rays lah, okay, which is something like this, okay, here and here, and it goes like that lah in the so here you can have let's see, I add another one, the green part, okay. The green part here is like this, okay, and it reflects here and it go up here and then it travels, it travels inside the multi-mode signal in the glass, by reflection of the signal, okay. So here you have multi-mode here is multi light rays, okay. So as you can see, okay, if you transmit physically, if you have a very small glasses, and the light can go straight, okay. So if it can go straight, it can cover more distance, okay. But if the light go through in the multi-mode here, it go up and down, so it it cannot go very far. Okay, the most you can go for multi-mode is 550 meter, which is half kilometers lah. Okay, so you can compare when you use single mode, you can go until 5 kilometer, but when you use multi-mode, you can only go for 0.5 kilometer, which is half kilometers. So that's the difference. Okay, but here you can have multiple signal ray. In this case, the blue, the green, and the red part lah. Okay, so that's it lah. Okay. Okay, so if you use single mode here, it's mentioned that you can get a high speed because the signal go very straight forward, okay, and it can cover long distance. But in multi-mode, because it go like this, okay, so there is more attenuation, and then you can the you cannot go as far as the single mode lah. Okay, so so it's not capable to support over longer distance. So very short distance, 0.5 kilometers lah. The most it can go. Okay, that's the difference. Okay, so let's look at the serial. Okay, the serial here, okay, serial cable, if you make this slide bigger, you can see here that you will have what do you call this, in the serial cable, you can have many pins. Okay, many pins here. Okay, P-I-N-S. Okay, many pins here. Okay, so this one, this serial cable ni is being used all this while from starting of TCP/IP. This cable is being used. Okay, so it says that it's a legacy form of data transmission. Okay, and it continue to evolve. And in fact, the one that we use, the USB now, USB is a serial technology. Okay, so there's so many types, RS232, 422, so many types. Okay, and this RS stand for recommended standard. Okay, so this serial connection is designed to support the transmission of data as a serial stream of bits. Okay, so now let us look at the content of this pin. Okay, so I'll share you, okay, the detail. Okay, let me see. Okay, so here you have, hold on, share screen, I guess. Okay, okay, so the pin that I told you just now, the pins there. Okay, so you can have when you use this serial cable, okay, you must use in a pair of male and female. Okay, so normally, okay, this is being used in DTE and DCE. So I hope you know what is this. Okay, so basically you can see that every pins have their own function. Okay, let's say for example, you can have a carrier detection in pin number 1. Okay, you can receive data in pin number 2. Okay, and you can transmit data in pin number 3. Okay, and many more signals. Okay, many more signals that you can transmit over this pin. Okay, so basically, if let's say for example here, here you have I take only one pin lah. pin number 2 here is to transmit data. Okay, you transmit data here, and it goes to pin number 2 here is to receive. Okay, to receive. So it goes here, from here, it goes to here. Okay, so that is the way this serial cable is being used. Okay, so and every bit in this pin is sent in the serial stream of data, serial stream of bits lah. Okay, so that is what it means by serial cable. Okay, and so let's stop sharing. Okay, so here I hope that I won't miss some information here. Okay, so the current this serial technologies ni, the current currently we use okay, USB, firewire, but normally we use USB ni, is a serial technologies. Okay, and I guess I need to stop here. Okay, little bit. I'll continue. I'll continue later. Okay, before we go to this part, okay, signal data encoding, I forgot to share with you the baseband and the broadband, the difference. Okay, so as you can see here, if we use broadband, okay, baseband, okay, only single frequency is being used here, okay, for all type of data here. Okay, so but if you use broadband, okay, they always they can differentiate the frequency. Okay, so if video here, you can see that it is high frequency. Voice so for voice here, okay, also different frequency, the blue frequency. And if you send a data, so you can use this red frequency. Okay, so there are multiple frequency in a signal, okay, in a channel. Okay, but for baseband that being used by Ethernet, you use only one frequency. Okay, and here because you share multiple frequency, you can use FDM, frequency division multiplexer. Okay, you can use FDM in order to multiplex, okay, and demultiplex your frequency, this FDM. Okay, and what happened to this TDM, this baseband in Ethernet? You can multiplex all this signal by using time division multiplexing. Okay, so I guess you will already learn this, okay, in datacom. But let me share with you the example. Okay, so here, okay, you can see that, okay, this is a different way in representing baseband and broadband. Okay, so okay, so I use red color. Okay, as mana pen ni? Hold on. Okay, write something here. No, is it okay to? Okay. So for baseband, okay, just now, so you can have, let's say, for example, this is client number 1, client number 2, okay, and this is client number 3, okay, number 3. So what you can have in baseband in TDM, Okay, in time division multiplexing. So if you forgot this, you can check your datacom slides. Okay, whereby you can have this client number 1, okay, client number 2 here, and client number 3 to connect to a multiplexer where you can form, okay, this client number 1 in and client number 2. This is number 1, okay, this for client number 1. Oh, very difficult to name. This is number 2 for client number 2, okay. This is the third slot for client number 3. Okay, so this one here for client number 1, this 2 here for client number 2, and this 3 here is for client number 3. So remember that when you use TDM, the time too is shared. So here, okay, normally what you have here, okay, is like this, okay. I hope you can see this, okay. So this is time slot, okay. As I draw back whatever here to here. This is frequency, okay. So with the same frequency, okay, you can share, okay, you can share in different time slot. Okay, this is for client number 1, this is for client number 2, and this is client number 3. This is time. So for client number 1, they have their own time slot. Client number 3 also have their own time slot. So they share time in the not they share time. I mean, they have, okay, every client have their own time slot, okay, in a frame. Okay, please check back your datacom notes, then you can probably understand this baseband, what it mean by this baseband and TDM. Okay, okay, so let's move to signal data encoding. Okay, okay. Before I go to this part, I hope you know that when we receive a packet, okay. So when we receive a packet, what we do before we transmit, we encapsulate to become frame, okay. And from frame, we do an encoding, okay. Encoding, this part is to change from bits to become a signal. Okay, so encoding is the process, okay, to convert the bits to 101011 to become a signal, okay, become a signal. So that is what it mean by encoding. So I've give you the video. I hope you can watch that video. I've give you the video of Manchester encode, Manchester code. Okay. So have a look at it, and you can understand how, okay, how you represent the 0 and 1 value, I mean the bits from the frame, okay, the bits from the frame 0 and 1 to how you translate it, okay, in a wave form, okay, and by using uh, uh, the voltage, the current voltage lah, okay. The current level voltage. Okay, so let's look at some example. Okay, so here I just capture the one in the video lah. Okay, nothing much. Okay, it's just this part that I capture. Whereby, okay, let me share this. Okay, I hope you can see this. Okay, to here. Okay, so I'm choosing blue. And okay, so here is example of Manchester code, okay, that represent 0 and 1. They mentioned there, this part is 0 lah, and 1 is when you go up to to highest vote. Okay, so here is the baseline. Okay, uh, and where, let's say for example, here you have 5 vote. Okay, and here let's say for example you have 0 vote. Okay, so this is the way you represent lah, the wave form. Okay, and translate all the bits here become a waveform by letting the vote tu. You represent the vote lah. If 0, it means that from 5 become 0 vote. Okay, if 1 is like from 0 become 5 volt. Okay, so if you use this, then you can represent this bit to become this digital signal. Okay, that is what the Manchester codes lah. Okay, one thing that I want to you to observe is on the clocking. Okay, before I go there, okay, I need to really stop sharing this. Okay, I want to talk about the purpose. Okay, the main purpose. Okay, of encoding. Clear my notation first. Okay, the main purpose of encoding is to, so okay, the main purpose, okay, of the encoding this signal is to ensure that a synchronization. Okay, and now you have a new term here, synchronization or clocking between sender and receiver over the physical medium. Okay, this part tells you what is encoding. Okay, encoding is to represent 0 and 1 to become waveform and translated by where the voltage is translated into binary 0 and 1. Okay, this is the definition lah. Okay, the definition of encoding. Okay, okay, but one of the most important part before I go there, this one is NR, non NRZI, non-written 0. Okay, so before I go there, okay, it's mentioned here that encoding by definition is to translate from bits to become to signal. That is one part. Another part, the main purpose of this encoding is to do synchronization. Okay, so what it means by synchronization, this clocking part lah. Okay, so what is this? Okay? So basically, what is it? So you can see it here, okay? This is the same slide that I the same thing lah, that I use here, the same figure here, okay? Basically, this, okay, the sender and the receiver, okay, here you have sender and receiver, let's say here, and you have a physical medium here, and you have a sender and receiver, they must synchronize. Okay, they must synchronize. So what it means by that, it means that both of them, okay, must have the same clocking. Okay, clocking. So this one is just a simple example on this clocking. You can see the dot here. Okay, the dot here Dia pakai dah. Okay. Okay. Oh. Hold on, the dot here. It can represent the clock. Okay. So how do I use this? Okay. So you have a dot here. Okay. This dot. Oh. Okay, just okay. This part, this dot. So this one is the clocking, the clocking part. So when you start the clock, then only you can encode. Okay. Another clock ticking, sometimes we call it as a clock pulse. Okay. So when the clock ticking, then you can do the next encode. So for sender, okay, let's say sender have this clocking, okay, and for receiver, for example, okay, receiver also must have the same clock, okay, the same clocking. Receiver must also have the same clock. Here I show probably some example of different clocking. Okay, let's say for example, the blue part is the receiver. Okay, the receiver, the clocking is this. Let's say this one is one one clock. Okay, one tick. Okay, so you can see when you represent the bits, it will be different because sender here, this sender, the clock ticking is very fast. Okay, but the receiver here, the clock ticking is very slow. So when you want to transmit from sender to receiver, you must synchronize the clocking. Okay, so what the receiver and sender must agree is they must agree on this clocking tick, clocking pass. Okay, so basically, okay, clear my annotation. Basically, if sender here also have the same clocking with the this is receiver, for example, the clocking for sender must be same. Okay, so that when you represent the bits, it's going to be synchronized. Okay, so that is what it mean by synchronized lah. So the data itself is important, but also the clocking part is also important, inline encoding, so that both part will whatever that the sender produce will be sent to the receiver. Okay, the data itself is okay, and also the clocking must also be synchronized. You cannot have a sender with a very fast clocking and the receiver very slow clocking. Okay, you cannot have that. You must have the same pace lah. So the sender and receiver must synchronize the clocking. Okay, so this clocking is nothing much lah, kan? When you learn CPU clock, clocking is same. Okay, when the clock tick, then the CPU do something. Okay, that's that you learn that in the computer organization. You learn that already learned that lah. Okay, so this is what it mean lah. Okay, from this statement, what it mean by this statement. Okay, let me clear. Okay, so the signal that you transfer, the signal that you send, you must make sure that the clocking part of sender between sender and receiver must be synchronized. Okay, so that the signal in the form that can be interpreted by both sender and receiver. Okay, Okay, you cannot have receiver and sender different clocking pulse. Okay, so that is the one of the purpose of line encoding. Okay, before I go further, okay, I also want to share with you. I guess this one I already shared. Okay, I want to just remind you that how do we apa tu, the whole process of this from packet to become a signal tu, what will be the process there is this lah. Okay, you have a packet here. Okay, and this packet will be encapsulated to become a frame by CU. Okay, this one you can refer to the books lah. So this packet, continue. So this packet, okay, this packet will be encapsulate to become frame. Okay, this one I already mentioned to you. Okay, packet encapsulate become frame. Okay, and then what happened? This frame will be put in the outgoing buffer. Okay, this one is the outgoing buffer. They will put in the outgoing buffer, and then you have this LC. Okay, LC is a line coding. Okay, the one that we go through just now lah, Manchester code. Okay, Manchester code, something like that lah. Okay, here, and then from frame, okay, you do the encoding LC here, and then you transmit. Okay, UTX transmit. So now it become a signal lah. Okay, frame here is a bits. You do the encoding and you do the clocking, synchronize the clocking, then generate a signal and it will be transmit from the network card. This is a structure of a network card. Okay, so at the receiving part, okay, when you receive the signal, okay, when you receive the signal, what you must do is you must do decode. So LD here is line decode. Okay, line decode. You must change the signal to become bits and okay, form a frame. That frame you put in the ingoing buffer, and then you process, you decapsulate that frame to become a packet. Okay, that is what happened lah. Okay, so I want to emphasize on this line encoding LC. And decoding ni, line decoding here, okay, LD, it happened, the process happened in the network card, okay. Alright, so okay, you can check what is Manchester encoding. It's being used by fast Ethernet, and also I guess this one you have to memorize lah, probably. The gigabit Ethernet are using 8B and /10B line encoding. This is for you to check by yourself what is the difference between this encoding technique. Okay, I'm not going to cover it here. Okay, so I guess I again have to stop this and I continue this later. Okay. Okay, so let's continue. Okay. Collision domain. Okay, we already go through this actually. This one is also a repetition, okay, of the one that we already learned when we cover the Ethernet. Okay, try to look at the video and you notice that lah. Okay, so signals ni, when you transmit in the shared network, okay, there will be a collision. Okay, shared network ni, I guess just now I already explained to you what it mean by this shared network. Okay, so basically, okay, last time we have this shared network okay. Nowadays we have switch switch network. Okay, so we already covered this. So shared network ni basically is a bus topology. Okay, like this. Okay, this one is bus. Okay, and okay, the host, the network card. Okay, the network card here. Okay, okay, so the host or the host itself, last time the network card, they only have a what we call this, half duplex. Okay, half duplex. I guess the slides that explain about this half duplex is in the next slide. Duplex modes. And also, okay, the topology itself is bus. The host is or the network card is half duplex, and the cable, okay, the cable itself, okay. So if you are using Cat2 or Cat3, okay, which is using a coaxial cable here, okay. So this is also half duplex, okay. So any technology that are half duplex will collide. The signal you will have a collision. Okay, you will have a collision in the shared network. And shared network, number one, the topology is bus. Number two, the host or the network card is half duplex. Number three, the cable itself, the cable that you use here, the cable, not the network card, the cable itself is coaxial cable, for example. It is also half duplex. And number four, okay, that we didn't mention anything about this in the Ethernet slides, is the device too, whether it is a switch or hub. Okay, so if you use hub, okay, okay, then it is the signal can collide because it is a half duplex. Why? Because even though you use a star topology, okay, but even though this is a star topology, meaning that this is PC1, this is PC2, for example, this is PC number 3, yeah. Even though you use a star, this one is a star topology, okay. Even though you use star topology, if you use hub, okay, normal hub, then you can collide because hub is a layer one device. What it means by the layer one device? It means that whatever that PC1 send will be transmit to PC number 2 and PC number 3. Okay. Okay. Layer one means physical. The physical layer is shared. Okay, so if data come from PC number 1, will also be for PC number 2 also will receive, and PC number 3 will also receive the same bits. Okay, any bit sending from PC number 2 will also be sent to PC 1 and PC 3. This is hub. So the characteristic of hub. So if you have these four combination, then you will face a collision. Okay, so but nowadays the trend of this network it changed. It changed to most of the time you already look at the lab or for link aggregation, the topology for LAN nowadays are using star topology. Okay, so you can have router here, and then you also have switch, okay, core switch here, for example. Okay, and then you link this, and then here you have another switch, and then you have PC 1, 2, 3, all the client, okay, connect to. This is typically is a star topology lah. Many star topology become three lah, three punya topology, but the basic topology is star. Okay, star topology. This is the current design of LAN now are using star topology. Okay, so star topology itself, the topology itself will you won't collide lah, okay? Unless if you use, as I mentioned just now, even though you use star topology, but if you use the device is hub to link all these PC, then there will be also a collision, okay? So this one is the general term that number one, the topology is star. Number two, the host itself, the current network card now, okay, they support full duplex. Okay, this one I will explain after this. I guess I already explained it. If you watch the video of Ethernet, I already explained this, but I repeat again and again lah. Okay, number two, the host. The host is full duplex. The network card itself. Now, they enable this full duplex, okay, in current network card. Okay, so number three, okay, so we will look into the detail, the full duplex mode of the network card later. The cable now are using twisted, okay, twisted, using fiber optic, okay. So all this type of cable, I mean Cat 5, Cat 5e, Cat 4, okay, Cat 6, Cat 7 just now. These are all full duplex, okay, full duplex. Meaning that, okay, because this is twisted cable, kan? So you can send and receive a signal on the same time. The cable itself is full duplex. And number four, okay, the device must be switched, okay, or switch or routers lah, okay. So if you use switch, okay, not hub, not hub, okay. If you use switch and you use this type of cable, twisted fiber optic cable, and you use a network card that are full duplex, and you use star topology, okay, there will be no collision, okay. This is mentioned in the next slide, okay. So this four aspect, normally we call it as a switch network, okay. So the Ethernet move from share network, okay, they call it TICnet just now, to become a switch network. So switch network is a fast Ethernet, gigabit Ethernet, that is a switch network lah, okay. Okay, so let's look at, we already go through that, okay, but repeat this lah, okay. So you have a half duplex and full duplex in the network card. So half duplex means non-simultaneous, okay. Full duplex means simultaneous lah, okay. So you can send and receive on the same time, okay. This is what it mean by full duplex. On the same time you send, you can also receive, okay. So but half duplex is like walkie-talkie, okay. So you when you send, you cannot receive, okay, on the same time, okay. But when you receive, you cannot send, okay. So that is half duplex. So whatever that I mentioned half duplex ni, it is part of collision domain, okay. Half duplex in term of cable, half duplex in term of the network card, half duplex in term of the bus topology, for example. So the collision will occur, and when collision occurs, you know what to do lah. You use CSMA CD. Okay. Okay. So if it's mentioned here that if it's a full duplex, okay, so you can send and receive on the same time, okay, over point-to-point wire pass, mentioned that. There is no potential of collision to occur, okay. Thus, there is no requirement for CSMA CD, okay. So that's what is mentioned here. Okay, so I hope you remember that we already go through, okay, this part. Mana? mentioned about. Okay, so I'm using the same slide here. Okay, so when we say it is a full duplex, okay, full duplex means that before you transmit, this is transmitter, right? Before you transmit, you have to check. Okay, so half duplex. Okay, half duplex in the network card means, in the network card or in the host here, means that when you want to transmit, you must check the receiving signal. Okay, if there is a receiving signal here, you cannot send. Okay, so if this one is apa tu, if Rx, okay, is currently receive a signal, you cannot send. Okay, that is half duplex. Okay, and for full duplex, okay, you don't care much on the receiving side. Okay, meaning that so for full duplex here, okay, for full duplex, when you want to send, you just send it. Okay, even though there is a signal, incoming signal, is okay, because full duplex, you can send and you can receive on the same time. Okay, that is what it means by full duplex. Okay, but half is different. When you want to send, you cannot receive. Okay, so basically, if you have a receiving a signal, you cannot send. Okay, so that is half duplex. So I guess apa tu that's the meaning of this duplex modes here. Okay, and apa to when collision happen, what to do lah in CSMACD. If collision occurs, so you need to back off and then pick some random time for you to access again. Okay, so it's mentioned here. Before you transmit, you must sense the signal, the receiving signal first. Okay, if the receiving signal is idle, okay, it's okay, then you send it. But if it's busy, so what you do, you must try to access again. Try to access again after some time. Okay. Okay, so let's say you sense the channel is okay. Okay, nobody are using the channel. The receiving channel is okay. So now you proceed and send your signal. But okay, if a collision occurs, so what you do, you back off. You stop, and then you take some time, a random value of time. Then you re-access again, okay, or we call this, here is mentioned, retransmission can be re-attempt. You try to access again. Okay, that is how CSMACD works. Okay, so I guess this one is the last part. Okay, so happy. Which form of cabling can be used to support gigabit Ethernet? Gigabit Ethernet, they can use Cat 5e and above. Okay, this one you have to memorize. Okay, Cat 5e, 6, 7, okay, and any form of fiber optic can be used by gigabit Ethernet. Okay, this kind of cable support gigabit Ethernet. Okay, so what is a collision domain? Okay, collision domain is a network segment for which the same physical medium is used in two ways communication. Okay, you can send and receive bidirectional communication means that when you send, you cannot, when you receive, no, when your receiving signal is busy, that you cannot transmit. That is what it means by collision will happen okay, if you try to send and receive on the same time in a bi-directional communication, okay. Okay, so basically when collision domain ni is when the 4 parts lah, bus, and then you have half duplex of network card, okay, or host, and you have half duplex of cable. It means that you use coaxial cable, okay. And another one is when your what is this again? 1, 2, 3 half duplex, and if you use hub, okay. So this combination will create, if you have this, then you are part of a collision domain, okay. So what is the purpose of CSMACD? CSMACD is to detect and minimize collision. It cannot it cannot make the collision don't occur, no, okay. Collision will occur, collision will happen. The CSMACD is to detect and to only minimize, okay. You cannot prevent 100%, okay. If you have this type of network, this type, as I mentioned for just now, bus, the host is half duplex, the cable is also half duplex, and using hub, you cannot, collision will occur, you cannot make it 100% no collision, no, okay. Because of what? Because of maybe the host access on the same time, okay. And also this one I already told you in detail, the propagation delay, okay. I don't want to repeat it here, just listen carefully on the Ethernet videos, okay, and then you know lah, okay. Propagation delay, so these two will happen, okay. So you will find out that CSMACD is not to make 0% collision, no, okay. Collision tu also happen, okay. You can minimize, you can detect and minimize it, okay. So here is mentioned about the mechanism, okay. You first listen for any incoming signal. If there is no transmission, then you can proceed, and then if you proceed, then the collision occurs, you back off for some period of time, and then you transmit again, okay. Okay, so I guess that's all. Thank you.